For this topic, what we will be doing is factoring out a monomial. We have topic AA.2. When you are factoring, what you are doing is you are dividing out from your expression. So for example, here in this one, we have 3R3 plus 9R2. Now, whenever you're factoring out, you need to find the greatest common factor. In other words, what is the biggest number that you can divide out of the terms that you are given? So because my numbers are 3 and 9, my greatest common factor of those is going to be 3. Greatest common factor is 3. Because I can divide both the 3 and the 9 by that number. Then from there, we also have to find the greatest common factor in the variables, if any. So if you look at the first term, we have a total of 3 r's there. R to the power of 3 means that you have r times r times r. And r to the power of 2 means that you have r times r. So the greatest common factor for the r's, or how many you can divide out of each of those terms, is you can divide out 2 of them, because there is at least 2 in both of the terms. So the greatest common factor is r squared. So then we're going to be taking that out of our expression, out of our term. So we have 3r squared parentheses. Now since we're dividing this out, what is going to be left inside? So if we take our first term, 3 divided by 3, that's 1. R to the power of 3, we divided that by r to the power of 2. In other words, we took 2 of them out. So how many are left inside here? Just 1. So r plus, and then we had 9 divided by 3. That gives me 3. R squared divided by r squared. So we took out both of them. That means that there is no r's left inside of that. And that will be my answer there. I've completed factoring out the expression. I'm going to go ahead and type that in. I have 3r power of 2. Click on the side to move it down. Parentheses 1r plus 3. Close parentheses. You need to remember to close the parentheses, because if you do not close the parentheses, you might get the answer wrong, even if you had the rest of it correct. Okay, so let's look at this next example. I have 4q to the power of 3 plus 8q to the power of 2. So very similar as before, what is it that I can factor out for the number for both of these? My greatest common factor. Now, I like this example better than the last one. Why? Because I could easily divide both of these numbers by 2. But if I divide them both by 2, then here my result will be 2, and here I would be 4. I could still divide that further by 2. Divide. But that I want to try to avoid that. So what I'm going to do is, that's why we need the greatest common factor. We need to find the biggest number that divides both of these. So the number for that will be 4. 4 divides both the 4 and the 8, and you cannot go any larger than that, because then you'd be having fractions with the 4. And then your greatest common factor for the variable, same as before, you have q times q times q and q times q. How many can I take out of both of these terms? I can take 2 out of each of them. So q to the power of 2 is what I can factor out for the variable. So then what I'll have is 4q2, that's what I was able to factor out, parentheses, and what's left inside? 4 divided by 4, that's 1. q3 divided by q2, so that means I took 2 of them out. I'm just left with 1q, plus 8 divided by 4, that is 2, Now here, I was about to make that mistake there. I no longer have the q. Why? Because I had q to the power of 2, and I divided that out, so that one now moves out here. I don't have any more q in there. So then that will be my final result. Go ahead and type that answer in. 4q at power of 2, parentheses, 1q plus 2. Don't forget to close the parentheses. Okay, so a lot of the first examples are very, very similar to that. I'm going to do this one more, and then I'm going to jump a level into the next questions. So this one we have, if at any point you need to pause the video, make sure you pause it so you can, if you need to write down the notes, look at the steps more closely, or see what I did in each of the steps. So then here I have 4w squared minus 6w. My greatest common factor for the numbers is, can I divide both of them by 4? This one I can't, because the 6 doesn't divide the 4 evenly. So for this one, I would have to use a 2. You just have to check what works for all of them. And then for the variables, the greatest common factor, here I have w times w, and here I have w. That means I can take out 1 from each of them, so then I'll just be able, my greatest common factor for the variable will be a w. So then I'll have 2w, that's what I factored out. And then what's left? Well, I have to take the 4w squared, divide 4 by 2, that's going to be 2. W squared, I took out 1w, so I have just 1 left, minus 6 divided by 2, that's 3. W divided by w, so that 1w I took out, I no longer have it inside, and that completes my expression. Remember, if at any point might be going too fast, just make sure you pause the video, or you can use the feature to slow down the video a little bit on YouTube. You can write any notes, and if you have questions on any of these, make sure you ask me on Google Classroom. Don't hesitate to ask. If you're having trouble, just let me know, and I can help you with this. Okay. So I'm going to go ahead and jump up a level. This is very similar, so they're going to keep being the same type of question. This is still the same type of question. So from both of these numbers, I could divide out a 5 and a u squared. I'm going to jump up another level because this is still very, very similar. Okay, I'm going to jump up another level. Here we go. So in this type of example, the same process that we were doing applies, but now you have to check greatest common factor between all 3 parts of the expression. So what is something that I can divide all 3 of these terms by? I can divide all of them by the number 5. Right, that is the greatest number that I can divide all of them by. So my greatest common factor is 5. Now I'm not going to write all the u's for this because there is a lot. There's 9 u's, 8 u's, and 7 u's. So how many could I take out of all of these 3 terms, or what's the least amount that they all have in common? That would be the 7. Okay, so my greatest common factor for the variables is 7 u's. So u 7. Right. If I was to do 6, then I would still have 1 left over here, but I could have taken that out. If I do 8 instead of 7, then I'm taking out more than I can from this one. So that will not work. So I'm dividing everything here by 5. That means that outside of my expression, I will have 5 u to the power of 7. Okay, so 20 divided by 5, that's 4. u9 divided by u7. So from the 9 that we had, I was able to divide out 7 of them. That means I'm going to be left with 2 of them. Minus, and then again 20 divided by 5, that's 4. And then u, I had 8, I was able to divide 7 of them out, so then I have just 1 left. Minus, and then 5 divided by 5, that's 1. U7 divided by U7, so I took all of them out. Then I don't have any more U's there, so then that will complete my expression. So I have 5u exponent 7 parentheses 4u exponent 2 minus 4u minus 1 close parentheses. Okay, so that's going to be my answer for that one. And then the rest of these will be very, very similar. The only thing that they are doing is that they are going to be making the numbers a little bit bigger. So I'm just going to go ahead and work on this last one, and then that'll be it for this topic. Just try to get as far as you can. If you get to a point where you're just going back and back, then just stop there. That's more than enough. So here I have 42y8 minus 30y7. So I'm going to have to do a little bit more work on this one. Why? Because I have to find the greatest common factor of both of these numbers. So some of the numbers that divide the number 42 are 2, 6, and 7. There might be more. Let's see, 42 divided by 4, I don't think that works. No. Okay, so once you divide by 2, that means that the number that's going to divide this is 21. So these are the numbers that divide 42. The numbers that divide 30 are 10, 2, 15, 5, 6, there might be one more I'm forgetting, 3. Okay, so here now I've done a little bit more work. You're going to have to, for some of these, you're going to have to do the same. And we're going to find what is the greatest number that divides both of these together. So what divides the 42 and the 30, but the largest number for both of them. So for this one, it'll be 6. So my greatest common factor for this expression will be a 6 for the number. And for the variable, my greatest common factor will be y of 7, because I can divide a total of 7 out of both of them. So I'm going to have 6y to the power of 7, open a parentheses. 42 divided by 6, that is 7. If I had y to the power of 8 and I took 7 of them away, or divided them out, that means I have just 1 left. Now, I kind of didn't mention this before, but it should be assumed by now that you've gone over this before. Remember that if a variable does not have an exponent, the exponent for that is a 1. And then minus. So, for example, here I have a 1, but I don't have to write that. Only when it's a number bigger than 1 do I have to write that. Then 30 divided by 6, that's 5. I had y7, I have to divide out all of them. So that means I'm taking it out. It's no longer going to be there. So that will be my final expression, or my final answer. So here I have 6y exponent 7 parentheses 7y minus 5. Okay. In this example, and you might see a few of these. I said that was going to be the last one, but just this last one. So if you look at this setup here, 11 and 18, and it's try to find what numbers divide them. Well, 11 is a prime number. That means nothing else divides it except 1. So for this expression, I will not have a factor. That means that my answer will be just 1. So if the greatest common factor is 1, then just retype the polynomial. So I was going to get that wrong. So I don't have to do anything to it. I'm just going to leave it the same way that it is. Just like that. Why? Because nothing can divide the 11 and the 18 at the same time.